Hello and good day everyone. In this video we will be discussing Newton's second law, tension force involving friction force. For the introduction, I will be specifically explain about what Newton's law is. Firstly, mechanics is defined as a branch of applied mathematics and physical science that deals with energy and forces producing motion. In our case, we will focus on Newton's law. In general, Newton's laws are defined as a motion of three basic laws of classical mechanics that describe the relationship between the motion of an object and the force acting on it. The three types of Newton's law are: firstly, Newton's first law. It is when a body will not start moving unless an external force acts on it. Once it is set in motion, it will not stop or change its velocity until some force acts upon it once more. The first law of motion is sometimes also known as the law of inertia. For example, when the bus stops suddenly, people fall forward. Next, Newton's second law. It is when a force acting on a body is equal to the acceleration of the body times its mass. Expressed mathematically, F equals to ma, where F is the force in newtons, m is the mass of the body in kilograms, and a is the acceleration in meters. The example for Newton's second law is pushing a car. Lastly, Newton's third law. It is when two bodies exert forces on each other. These forces have the same magnitude but opposite directions, such as when you jump, your legs apply a force to the ground. Then the ground applies an equal and opposite reaction force that propels you into the air. That is all for the introduction. Next, we will discuss how to solve questions related to Newton's second law, tension force involving friction force.
Next is this discussion. For this discussion, I will discuss what type of force will be used in this situation. The type that will be used is tension and friction force. Tension force is when an object is being pulled from two different sides. Friction is the resistance one surface has when sliding across another surface. Whenever there is contact between a surface and an object, friction comes into action. There will always be a small force of kinetic friction or static friction, and the tension force is determined by equating forces that balance each other. I will describe the situation that will be discussed in this video. Alia wants to move a box from one side to other side. However, due to the long distance, it will be a difficult job as it will require a lot of energy. So she has decided to use a pulley to make it easy for the box to move, where the box will be placed at one end and the other end will be hung with steel weighing 300 grams. Based on Alia's situation, the question that will be discussed after this is a box of books with a mass of 200 grams rests on a raw horizontal table. It is connected by a light inextensible string passing over a smooth pulley fixed to the edge of the table to rounded steel of mass 300 grams hanging freely vertically below the pulley. Given that the coefficient of friction between the box and the table is 0.16, find the acceleration of the system.
Hi everyone, now I will explain on how to solve the question based on real-life situation that have been explained by Dayang. Beside is the illustration of the situation. First, we need to know the direction of the acceleration. In this case, the acceleration will move to right and eventually move the box to the other side. Next, in order to find the acceleration, we need to consider both objects, which are the box and the steel. And as my friend has explained before, this case will include tension force and friction force. Let's look at the box. Use F equals to ma as reference. Based on direction of acceleration, we will obtain the equation tension force minus friction force equals to ma, where m is mass of the box and a is acceleration. The friction force formula is F equals to mu multiplied with R, where mu is the coefficient of friction. The coefficient of friction given is 0.16. Now, we will find the R from the formula R equals to mg. we will obtain R equals to 0.2 multiplied with G. Note that the mass must be in kilogram unit, means the mass of the box is 200 divided by 1000, we will obtain 0.2 kg. Therefore, we substitute all the values we have obtained into the equation. And in the end, we have T minus 0.032G equals to 0.2A. Next, equation on the steel. Since the steel hanging vertically, the acceleration will move downward. From that, we obtain W minus T equals to MA, where W is equals to R and equals to mg. Hence, we can calculate W equals to 0.3 multiplied with G. After that, substitute all values we have obtained into the equation. And in the end, we have 0.3G minus T equals to 0.3A. Now, we have two equations. We can find the acceleration by using simultaneous equation. We will arrange the equation based on the variable. To eliminate the tension force T, we will use addition. After that, we obtain 0.268G equals to 0.5A. Substitute G with 9.8 and solve the equation. Therefore, we will obtain A equals to 5.2528, or round off to 2 decimal places. We get acceleration is 5.25 meter per second square. I think that's all from me, and next member will continue.
For the conclusion, based on the calculation made by NABEEHA, the acceleration we found is 5.25 meter per second square, which means the acceleration shows how fast the box of books move when have been pulled by the rounded steels. To sum up everything that has been stated, Newton's second law provides the explanation for the behavior of objects upon which the force do not balance. The law states that unbalanced force cause objects to accelerate with an acceleration that is directly proportional to the net force and inversely proportional to the mass. These three laws tell us exactly how things move or sit still, like why you don't float out of bed or fall through the floor of your house. Newton's law controls how a car doesn't move even on a slope, how the bicycle moves fast or slow, how the leaf can go up and down, and basically how everything around us moves. So that's all from us, and we hope you enjoy it. Thank you.